All right. All you guys are going to do is follow my process. The process basically says the first thing we're going to do is we're going to replace f of x with y. The reason why we're doing that is basically just to get, because we're going to be doing a lot of algebra. So it's much easier to do algebra with y than it is with x. So step one is just to replace f of x with y. That's an easy step. I think everybody can do that on their homework, right? Good. Now, the next step is to replace y and x. You swap them. And basically, what that is graphically representing is reflecting over that y equals x line. Remember when we reflected? That produced the graph, right? So basically, all we're doing to represent that reflection is now we're going to swap the variables. That's representing that reflection that we talked about of the y equals x line. Now comes in the fun part. Step number 3 is solving for y. And this one is difficult because now you're solving for a variable that not only is there 2 of them, but one of them is on the denominator. So we have to go back and remind ourselves of our algebra skills on how we would solve a problem like this for y. The first thing that I like to do whenever I have a variable that I need to solve for is I want to get that variable off the denominator. So a lot of students remember to multiply by the reciprocal. I'm not going to want to multiply the whole reciprocal, because if I multiply by the reciprocal, I'm going to have y minus 1 in the denominator, right? So when I multiply the reciprocal over here, I'm still going to have y minus 1 in the denominator. My goal is to get y off of the denominator. So all I'm going to do is multiply both sides by y plus 1. What happens when you do that is, obviously, when you multiply by y minus 1 plus 1 in the numerator, and then it's in the denominator, those divide to give you 1, because they're exactly the same. Then over here, you have this, right? You can multiply those. Now, I can apply distributive property for this, because again, I want to solve for the y. So I'm going to apply distributive property over here. And therefore, I obtain xy plus x equals y minus 2. Does everybody follow me on this part so far? I just multiplied by what my denominator was on both sides to eliminate it. Now, we got to solve for a variable. And we have 2 of them. So there's 2 things we do. First thing we got to do is get the variable to the same side, right? It doesn't matter if it's a quadratic, a linear, whatever. If you're solving for a variable, you got to get all the variables to the same side. So I'm going to get the y to the left side. And then I have xy minus y plus x equals negative 2. Then I'm going to get rid of this x. So now I have xy minus y equals negative 2 minus x. All right, so here's another thing you guys need to remember. On a problem like this, all right, when we have 2 variables, there's 3 things that you guys have worked on so far. The first one is to combine like terms, right? For linear equations, that's what we did, was combine like terms. Well, we can't combine these because this one's being multiplied by an x and that one's not. So we can't combine. The next thing we learned was using like quadratics, right? If you had 1 was to another power, then you could set them equal to 0 and like factor them. Well, for 1, we can't factor them with setting it equal to 0. But I can factor them. You guys see that both of these terms share a y, correct? So what I can do is factor out a y. By factoring out a y, I'm left with x minus 1 equals negative 2 minus x. Now, do you guys see there's only one more operation that's being applied to the variable? And what is happening to the variable? It is being multiplied by x minus 1. So to undo multiplication by x minus 1, I have to divide by x minus 1. So therefore, I'll write the answer up here. I have y is equal to negative 2 minus x over x minus 1. Then all I simply need to do is step number 5 or 4. Replace y with f inverse. So it's not f raised to the negative 1. That is the way for us to represent what we say f inverse. Okay? So f with that -1, it's not to the power of -1. That's just what we use to represent f inverse. Okay?